Hello and welcome to this video on how rainbows are made. Rainbows are an example of light refraction and diffraction. What we see is the result of how light enters a drop of water and comes out at a very specific angle. In order to see a rainbow, specific circumstances must be met. What most people experience is light coming through a tiny drop of water. The angle of this light is refracted to create a rainbow, but that rainbow must be at 42 degrees relative to the position of the person observing it. Each individual color that comes out of it has its own wavelength. This is important when you look at the particular way light appears. It's always in the same order for the observer. Red being the longest wavelength will only bend at 42 degrees. This is why it is at the top. Violet light has the shortest wavelength. As a result, it bends to 40 degrees. This means it will appear towards the bottom of the rainbow. Because red light is longer, it will nearly always be on the outside edge, whether that is the top or the far side of a rainbow. This means that everything in between, red and violet, will be distributed according to a given wavelength. 42 degrees is what we will see red refracted from in a raindrop or out of a prism. The only way you're going to be able to get the red wavelength to that measurement and angle is if you have it drawn as an arc. Anything else and you won't get the right angle. That is assuming that we're using naturally occurring phenomena. Once you start bringing in synthetic setups or artificial arrangements such as a prism, you can get slight variances on this. The rainbow occurs because of two particular phenomena, refraction and reflection. Reflection is when light is sent in another direction. Refraction is when the light is broken up. Sunlight, otherwise known as white light, will enter the raindrop as a whole light range. That is the entire wavelength in one particular bit of light. As light encounters the raindrop or prism, it begins to break up, and this is the refraction. That dispersion of white light into the 7 colors that we're familiar with, red, orange, yellow, green, blue, indigo, and violet, will come out of it. This is what we see with a prism. When these 7 colors of light with their corresponding wavelengths hit the far side of the raindrop, the light from these is then reflected back out again. Unlike when it enters the raindrop, it does not become one light again or white light, but instead remains 7 distinct wavelengths. This ensures that what we observe is the light that enters it is concentrated into a small location and then reflected back out, but also broken up. This process can be made even more complicated again with a double rainbow. This occurs when a second rainbow is directly visible above the first rainbow. This second rainbow is also not as visible as the first. The colors aren't as strong. This occurs because the reflection occurs twice, and this is why we can observe 2 rainbows. The same raindrop is putting out the same light, just less of it in the second time. It is this breakdown and distribution of white light into the various wavelengths that allow the human body to perceive it as it is. Without the breakdown into those 7 distinct wavelengths, and the fact that the human body's eye has the ability to perceive different colors within a narrow range, we wouldn't know what a rainbow is. The rainbow itself isn't only refracting and reflecting visible light, it in fact refracts and reflects all light that enters it. This is why, even though we can only see the 7 colors that have been mentioned, the others also come out. They do come out in lower angles, but we can't see them. And since we can't see them, there's no observable way to know they're there without using devices that allow us to interpret what is happening. The circumstances of a rainbow's occurrence and observation are, to a degree, somewhat random. It requires the confluence of certain events in such a way that it almost seems as though it shouldn't happen, But when it does, it is why the rainbow has nearly always been historically attributed to mystical origins or to have mystical properties. How much does it take to understand that light is made up of multiple wavelengths, the angles at which it moves in and out of things, that refraction and reflection are a phenomena, and just how all this goes together? It took a long time to understand it, and it's only in the last few hundred years that the human species has been able to get that degree of understanding of our universe. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below